If you ask me, this is the really good stuff. The geothermal earth coupling, taking advantage of earth temperature, running it through a slab. And if you're pre-construction with your design, can't beat it. Energy efficient ratio is 4.5 to 1 unit in, 4.5 units out. Well, you can recover your investment, but if you're coming back to retrofit, maybe it's not quite as easy to do. So put it in your plans to begin with. Let's look at some more of this.
Here at Ingram's Water and Air, we find it beneficial to you, the customer, to see firsthand what it is we do. In this short video, we're going to replace an older Climate Master heat pump with a new McQuay geothermal heat pump. First step was determining the existing size of the geothermal unit. This is found on the model and serial tag normally located on the front panel of the unit. Once determining the BTU, the next step is determining if the unit is left or right-hand return. On this unit, the return air is on the right side facing the water inlet and outlet ports, so it is a right-hand return. Normally, the water inlet and outlet connections will be on the same side as the return air, opening in this case the right side. We also needed to verify that...
So notice here the grommets on, instead of the other unit, it had solid bolts, washers, and then it had grommets in the rafters. This one here, I kind of like this idea. Probably has the rubber on both in the rafters and on the unit itself to quiet it down.
The existing ground loop was of sufficient length and depth, and that the circulation pump had sufficient volume for the system.
Notice too that this is an air circulation system.
Once we had this info, the next step was to decide which geothermal unit to purchase. We found many brands were offered, but only a few with a higher energy efficiency than others on the market. The McQuay unit was built with high-quality internal components and had higher energy efficiency at a very economical price. The great thing was the McQuay unit matched the size of the existing Climate Master unit, which made the changeout a breeze. Here, we are securing the McQuay heat pump to a vibration isolator attached securely to the ceiling trusses. This is a great way to reduce any duct vibration noise from the unit. After the unit is leveled, the next step is attaching the return duct to the new McQuay geothermal unit. Make sure all seams are taped. Next, connecting the inlet and outlet water lines, purging air from the coil, repressurizing the loop pipe. Next, tying in the existing thermostat wire and connecting the 220-volt electric to the unit. Now it's time for startup. Folks, it's that simple.
Well, yes, and notice the noise that the fan's making. So when you start moving air, then you do get into a noise issue. The radiant slab was a lot quieter. One of the issues with radiant slab, however, is air circulation. So you do need to make sure that you don't get a dank building by not having enough air movement. So there needs to be some air movement to keep the, even if you're radiant slab, still have to have some circulation, some air circulation.
For more info on new Energy Star geothermal heat pumps, call us or visit us online at betterwayac.com. Let us help you on your new geothermal install. All units offered qualify for the 30% tax credit with no maximum cap.
Let's take a closer look now at the purging and flushing of a ground source heat pump.
Hello, my name is Anthony Newman and I'm working for Eco Home Tech, and today we're going to show you how to purge a ground loop system on a ground source heat pump. Primarily when we're coming to do a commissioning on a heat pump system, which this particular one is a DeLonghi model, and as you can see we're in a very tight plant room at the moment, so I'm having to creak my neck. But you look at the installation as a whole, and basically you're just checking that all the necessary valves, which this one is for actually purging the ground loop.
Quick note here, you see the expansion canisters here, or chambers, so these have bladders in them to allow for expansion and contraction, and probably also might even provide an air scoop function to remove air from the system. Very important.
Which is a multi-fill 520. That valve's in the right position, and then all the necessary valves on the heating side are actually in the right position, and all the correct flexible hoses also. You've got the Takanova flow meter, which is what we use for actually checking flow rates to make sure we're working correctly. Strainers correctly fitted, and the same on the ground side, and correctly fitted and installed expansions and discharge pipes. So from this point we're actually going to show the purge pump working and connecting the pipes up. From actually connecting the pipework up now, we can actually fill our container or our equipment up to actually start the purging process, and hopefully they will have installed a filling loop point so we can actually do this very easily. So I will proceed to start filling the system up, and I will go down to the valve. We've basically backfilled our purge pump, so there's water in the pump now. And also from the filling loop we can actually fill our kit up. As you can see, we've had a bit of air in the system, so now I'm basically allowing the water to back.
And you see, your systems will have air bubbles that form on the walls, especially in your PEX pipe. So you need one of those air scoops. He hasn't mentioned that, but that's an important component, is the air scoop. And then you need a misting or a pressure relief valve besides the expansion chambers, the tanks. And notice that the purging trough is open. It's open air.
Filled our equipment. As we have now finished filling the container up, we've closed all our valves off, and we've actually closed the water coming to the unit and the valve, ready to go open the pipework in the field, which we will show you next. This is the ground loop manifold. It is an item produced by Franke in Germany, and this is a 4-port manifold, which we have 4 times 200 meter loops out in the field here. This, typically on a ground source system, you use a chamber and the manifolds are mounted underground. Well, in this particular instance the client wanted it above ground because he's building a stone wall, and he's actually going to encase this area around the manifold just for ease of maintenance more than anything, so it's above ground. This is sat under about 4 or 5 bar of pressure at the moment. We've got...
So that's another very good point, is when you start burying everything, you got to dig it up if there is any maintenance issues. And if you keep it above ground like this, you won't have flooding, so you won't have to, if you do, build a box that's subgrade, then you'll have drainage issues. So you want to make sure if you do have to put a box in below flood levels or below drainage, you got to have a pump in there, sump pump, or you got to have some type of French drain system where you gravel bed or something. But the best idea is just to put it in a box above ground, but then if you're in freezing temperatures, you got to keep that warm. So, got to balance your issues there.
It's isolated on the headers which go off to the back to the heat pump system, and with it being above ground, there are actually mechanical couplings as well. should ideally use mechanical couplings either above ground or in a chamber where you've got access to them. If not, it is good practice to use electrofusion couplings, but in this instance we're fine. So what I'm going to do is just drain a bit of the pressure off out of the system until we're at a static pressure, so we're not going to backfill our purge pump and kit inside the house. Right, now we've equalised the pressure in the system, we can open the valves into the header pipework, which is going back and connecting to the purge pump and our bucket in the actual plant room. And then what we're going to do, we're going to isolate 3 of the loops. Which there are your 3 pairs, and we're going to leave 1 open to actually purge this one part of the system, because we want to be able to get the full pressure and flow through 1 loop at a time to get rid of any air and debris out of the system, which is how you purge basically a typical ground source system. So on that note, we'll get back to the plant room. Now we've successfully purged the ground loop system, we've got to add the antifreeze into the system now. Effectively I've got 4 200-metre loops of 40mm pipe, which means we've got approximately 800 litres of water in the system. We've got 10 25-litre tubs of antifreeze, so what we're going to do, we're going to introduce just over 2 tubs per loop system, and as we're adding the antifreeze into the purging process, we're actually adding the antifreeze and we're going to discharge the clear water away from the system. So as we start pouring the neat antifreeze in, we're actually still bringing water around the system also. We've got, with this particular system, we've got approximately 5 minutes before the antifreeze starts coming back. So as our water level rises, we actually shut down, we can open our valve to discharge the water to outside, so we don't end up with too much fluid in our container. We are going to get the antifreeze in relatively quickly on this for the training purposes, but then as you switch over to the next loop, you basically want to time the system so you've almost got the correct amount of antifreeze in per loop, so it's mixed effectively. Now we have actually successfully finished purging our system. I'm happy we've got rid of all the air and the antifreeze is mixed in accordingly. We can now test the integrity and the percentage of antifreeze in the system by using a spectrometer. This will tell us if we've basically got enough antifreeze in the system. All we do, we take the actual unit with the pipette provided, we take a sample of the actual water, that is a pre-mixed antifreeze, place it on the actual spectrometer. At this point, when we view down the actual machine, we can actually see the amount of antifreeze. As I can see from this test, we have actually got protection down to -16. So in this particular instance, I'm quite happy with the successful purging of a ground source system. We have finally purged the system. Everything's back together. We've actually got a buffer tank full of hot water now, and the system is up and running. The only thing that the installer needs to do on this installation is insulate the ground loop pipework now to stop any condensation. Apart from that, we've got a good heat pump. If anybody would like any further information on the topics we've covered today, if you'd like to give us a ring on the number below, we'd be only too happy to help with any questions. Thank you and goodbye. Bye.
Might be long distance, huh? Call them in England. Okay, let's get down to the dirt now. Got to deal with the dirt, eh? Here we go.
The end of day 2 of construction. 100 feet from the other side of the house. So we excavated the trench for the well line across the house and the geothermal lines. We were originally going to put 3 separate trenches for geothermal, but given the conditions of the soil, large rocks, very tough digging, we opted to do a 15-foot wide trench, 100 feet long. We're going to run all 3 loops in that one field area. So we got it down about 7 feet on average, some places as much as 8 feet below grade. We're going to come in with a machine, we're going to grade that off a little bit more with a bobcat, and then we're going to fill it in with sand. Put down our geothermal lines, fill that in with sand on top, backfill a little bit, run our water line above that. We'll come across into the house here and come up into the utility room inside of the building. So even though this lot was nice and graded, the whole lot kind of looked like this at the end of yesterday. The whole lot looked like this. We had it nice and leveled off. We kind of made it look like a bomb went off today with the digging of the geothermal lines.
You can see the issue with this type of lateral. I would think ditching might have been a better, the ditch installation or horizontal drilling.
Today's the end of day 2. Day 3, we're waiting for the geothermal pipe to come in. This is the hole where we dug over here. Put a little ramp going down in there so we can pull the bobcat in and grade off the bottom and spread the sand out before we run our geothermal lines. Let me get a different angle. Here's a different view of the trench. The trench is a little over 100 feet long. We've actually been pumping for a while now. We set up a temporary pump set up into a well so we can get water on here and flood this thing as we fill the pipe in around the trench. We just fired that up today so we make sure we had some water. We're flooding a little bit of water in there now. We're going to be bringing a bobcat, grading off the bottom of this trench, spreading out about 6 inches of sand, laying our geothermal lines on top of that, putting about 6 inches of sand on top of that. We have 3 600-foot loops going into this trench, about 15 feet wide, average depth of 7 to 8 feet, supplying a 3-ton geothermal heat pump. So here's our geothermal trench. This is day 4. We had a ramp made.
So you notice for his application it was 600 feet, and he didn't say if it was 3/4 inch pipe, but 600 feet of pipe in the ground loop to supply 1 ton for the house, one ton of heating and cooling.
We went in with the bobcat, we graded off the bottom of this, down into the trench here, and all the way back out this way. We're waiting for our geothermal pipe to be delivered. Sand is supposed to be here at 11 o'clock, so it's running a little late. So we can go in there with a machine and spread some sand across the bottom of this trench before we lay the pipe in there. So that's where we're at. After we spread 6 inches of sand throughout the whole trench, graded the bottom, this is all prepared and ready for the geothermal lines to be set in place. So we have a little over 100-foot trench, about 30 feet of small trench going up underneath and into the house, but we're all prepared. We're just waiting for the hose to come in. We have 6 inches of sand laid for a base.
So I'm just guessing at the size of that excavation, is probably as much as $15,000 an excavation right there. If he was lucky, he got it done for $5,000. It depends.
Then we're going to cover this with 6 inches of sand afterwards. Alright, so
now the issue with these slinkies is cancellation. Where the pipe comes across, it tends to create what's called a cancellation effect, as far as taking the maximum amount of transfer from, if you're trying to gain heat or if you're trying to lose heat, you tend to kind of cancel that out as these cross over. So the slinky is not the best. I mean, it does give you a fair amount of space, or shall we say volume, in a small amount of space, but I'm not really impressed with the slinkies.
Monday evening, about 7:30, we didn't pick up our slinkies until we started building these about 4 o'clock this afternoon, 4:30 this afternoon. Alright, so these are our slinky loops. These are 2 600-foot coils, extend down through the hole, and run up into the, run up inside the utility room, inside the space. Come out, we're going to add one more of these slinky loops down this trench. We have a total of 600 feet of pipe right there. Tomorrow morning, after we build the last one, we will spread 6 inches of sand over the top of this, and then we'll be good to go.
And you can see here where they're more finalized here with the installation. You see where they've got the supply line coming on out here. Okay, this might be the return line, depending on whether you're trying to heat or cool. But the whole idea is that you don't want that in contact, or you don't want it to cancel out on the slinky loops themselves. So that some type of staking would be in order, because once you start pushing dirt over it, it can move that pipe around.
Alright, so here is the geothermal pipe slinky loops installed in the trench. You see it here, we actually have 3 lines, 3 600-foot runs of slinky loop. Take a little time to make those up. About an hour and a half per section to tie them all off to get the looping right. And they all run back into headers that run into this trench here under the house. They're going to come up inside the utility room. Now we're going to take this here, we're going to fill this with 6 inches of sand, wash it in good so we get good contact all around the pipe, and we're going to fill this in after a foot of sand. We're going to fill this in with regular soil and keep compacting that, and we should be done by the end of the day. We're starting to backfill the trench. We get sand and water. We're running water over the pipes to make sure we get good contact. So it washes all the sand right down in and around the pipes. We got good clean sand going over the pipes. And we're using a regular backfill over the top. You can see how the water washes that in nice and tight. Surrounds the pipes completely. Makes good contact. So we're coming down the ramp. So when you put a foot of sand over the top of the pipe, then we're filling it with regular backfill over the top, and we're going to compact this every 2 feet down this trench. So that's where we're at. Flooding just helps to wash the sand in so you have full contact with the pipe everywhere. You get no voids. Gets rid of the water, the air holes between the rocks and stuff. So. Alright, so we got the geothermal line buried about 2 feet. We ran a 4-inch pipe for our water line to run through. We're going to leave that end open so we can tie into the well. But we have this pipe run all the way down at a depth of about 5 feet. And we're going to backfill this into that trench and then run that up under the house. The geothermal lines are all buried. Got about a foot of sand on them, about a foot of dirt, and we're running the water lines above that. So that's where we're at. Alright, so our geothermal lines are just about done. You can see them coming up into the house, into the utility room here. We got a little fill around there to do and some grading off on this place. But they're all backfilled, all compacted. We're going to run over it a few more times, and we'll finish grading it off. Down the other end here, this is our water line. You can see our water line isn't in there. We ran 4-inch conduit to run the water line through. Our electrical line and some caution tape. We run caution tape about a foot above, foot to 18 inches above the electrical line, so if anybody ever excavates out here that they know before they hit that electric line. So the well guy's going to come in, he's going to tie this into the well here, drop the well in, and we'll be good on this end. So that's where we're at. The geothermal lines are pretty much completed. The field installation is completed. Once again, they're coming up. They're going to be coming up through the slab on grade floor way out there over in the house. We're just going to do some grading off around here a little bit more and start forming up for our foam, which is over there. That's our geofoam. It's going underneath the concrete foundation. We have 3 inches of rigid special geofoam, high density geofoam going under the entire slab of the house. So that's where we're at. Stay tuned.
So another thing to think about is that blue board, or geofoam he's calling it. The blue board, it can handle the weight of a slab. It won't compress underneath pretty good loads like concrete. I mean, you can't use it as a structural, like a bearing wall support or anything like that, but something that I've done with my construction too is to put the insulation on the outside of the concrete walls, the riser walls, from the foundation, from the footer on up, and use that thermal mass in the wall itself for heat storage. You've probably seen the forms that you pour concrete in. There's foam on both sides of the form to support the concrete. Okay, but if you rip the foam off on the inside wall, then you can radiate whatever, wood stove, whatever sun you can get into that, and use it as thermal mass. Got to insulate it though.